Hi guys, I'm Darren and this is the third episode in our iNav Beginners Academy. And in this episode, we actually get to iNav. So for the first two videos, if you haven't seen them, have been first selecting the model and our components that we're going to use, or using the plug and play if that's what you wish to do. I'll put a link for that one up. The second video, we're actually building the plane and getting it up to the plug and play standard. So in this video, what we're going to do is download iNav and start configuring that. Depending on how long this goes on for, I may not include everything in this video. We might break it down into a couple. The reason for that is because I really want to aim this out complete beginners. So I will be covering things that aren't usually covered because it's sort of assumed that people know. So iNav 5.0 was actually just released on Saturday. So what we're going to do is download it and get started. So what you need to do is, in your web browser, go to github.com/inavflight/inav-configurator. I'll put a link in the description. And what we're going to do is look at this releases section here. So we can just see here that the latest version is 5.0. In a month's time, there may be a 5.1. So if the version is different in the future, don't worry. You can install the latest stable version, which will always be shown here with the green logo. There may be some slight differences setting up in configurator, but if you learn about the basics in this series, there will also always be sort of installation videos for the latest current version. So all I'm going to do is click on this link here, and this will give us the release notes. This is probably the first time, I think, or one of the first times that there's actually been release notes with configurator, because there's been a couple of changes. They don't really affect you if you're new to iNav, but if you've used it in the past, the main things to note are that things have moved from the configuration page to outputs, OSD and GPS respectively. But where we're completely starting from scratch, we don't really need to worry about this. All we're going to do is download it. So to do that, if you're used to things like Betaflight, this will be quite straightforward. But if you're completely new, all we need to do is download the version for our operating system. So we have 32-bit and 64-bit Linux, we have macOS, and we also have 32-bit and 64-bit Windows. Now you notice that these are zip files at the moment. In the next version, there will be an option to use an installer. The reason we have the zip files is so that we can have multiple versions and it's easy to set up. But if you feel more comfortable with an installer, that's coming in the future. But for now, I'm just going to click on this iNav configurator Win64 because I'm using 64-bit Windows and it's 5.0.0. So we'll click that and I'm just going to download it to my desktop. Right, so now configurator is downloaded. Let me just close this. We don't actually need that anymore. And what you'll have is the zip file. If we double click it, we'll just get the contents and this folder here. For the time being, I'm just going to drag it and extract it to the desktop. Once that's done, you can close down this window. So once we have our folder, we could actually just delete the zip file. We don't need that anymore. We're going to run everything from this iNav configurator folder here. What I usually like to do on Windows is put it in program files. So what I'll do, I'll show you how to do that just in case you're a Windows user. Obviously, if you're Mac or Linux, this will not help you. But what I usually do is put it in my program files folder. So you notice I've got the older versions here already. So I'm going to drag that into program files. And I'm going to hold down the Shift key so that it moves it. And continue for the permissions. And what I'm going to do is rename the folder. So right click and rename. And I'm going to call it iNav configurator 5.0 because, as I mentioned, we can have multiple versions. So inside here, we just need to find the iNav configurator.exe file. If you don't see the .exe, it's fine. It's this blue icon here and it will just be called iNav configurator. Depending on how your version of Windows is set up, you will or won't see the exe. And we're just going to right click on that and go to copy. Now we can close that down. I'm going to right click on the desktop and go paste shortcut. Once the shortcut has been pasted, I just like to rename them. So again, if we right click and go rename, I put the version number first, so 5.0 iNav configurator. So now we're ready to go. So all we need to do is double click on this, and what we will get is this Windows protected message. All you need to do is click more info and run anyway. You won't see that again, it will just work in the future. So here we go, we now have our iNav configurator. Now I've got a couple of COM ports showing up, 7 and 8. I don't actually know what they're for. I know that they're not flight controllers. I must have something plugged in that it's recognizing. But anyway, this is our interface. If you're from Betaflight, this may look a bit familiar, but I would just stress, if you are from Betaflight, please pretty much disregard everything you know about Betaflight. Other than it looking similar, it works very different. So please learn how to use iNav rather than just expecting it to work like Betaflight. So now we've got iNav, we should really take a look at our flight controllers. So let's head over to the bench and we'll take a quick look at a flight controller and go over a few bits and pieces about it so that you know what it is and what it does. And then we'll start actually flashing iNav. So as I mentioned in one of the last videos, I'm actually going to use this flight controller here. Both of these flight controllers are in the document, however this one is now end of life, but it's close enough to the new version so we can still see what's going on. And all I'm going to do is take these out of the packets and we'll just go over a couple of things on the flight controllers so that you understand what we need to connect things to. So before actually doing the comparison, I thought it would be a good idea just to get everything out of the bag so you see what you get. What you get in the packet with both flight controllers is pretty much the same. The only thing I don't think that this one comes with is the capacitor, but capacitors aren't really expensive anyway. So there are pin headers, which you can solder to the board, so you can plug servo cables straight in. They're not soldered, so you will need to solder those on if you want to use them, or you can direct solder to the board. To be honest, I do either depending on the installation. Right, so in our little baggie, we have this device here, which is actually the USB connection, buzzer, and the DFU button. A really handy feature is the ability to turn the buzzer off, which it is at the moment. So when we're working on it, it won't be beeping at us, which is lovely. It's quite a loud buzzer on these. We also get a couple more cables with this flight controller because we can connect external I2C and CAN bus things. iNav doesn't support CAN bus, unfortunately, so we can't take any advantage of that. Also in the bag, there is the capacitor that I was talking about, which is a 470 microfarad 35 volt capacitor. So that is generally what you would put on an ESC to stop noise coming through, that sort of thing. In the diagram or on the Matex site, it will actually show it on the pads, but in the last build video, you'll notice that I put it straight on the ESC rather than putting it on these pads. And the reason for that is it is better on the ESC. The idea with capacitors in a noise prevention role is the closer it is to the thing that generates the noise, the better job it will do. So if you've got your ESC over here and your flight controller here, with the capacitor, we'll pretend that's the ESC just to make the visual a bit better. You've obviously got cables, so we've got our power and ground, our main power and ground here going to our ESC. So if this is generating noise, then that noise is going to get worse and worse as it travels along the cable. So putting this capacitor here, the amount of noise it can get rid of is the same at either end. But if the noise has amplified through the cable, this has got more noise that it has to try and get rid of, and it might not be able to do that. If we put it at this end, it gets rid of the noise before it's even gone down the cable. So at this end, you will end up with much less noise by just putting the capacitor on the ESC directly. You'll see that's what we've done in the build video. But yeah, let's put it back in the bag for now. We get some little black spacers for something. I guess they're spares for inside here. And we get some spare screws as well. Okay, so I was just building this up so that it would sit flush next to the other flight controller, and it reminded me of something that will be very useful for you guys when you're actually putting yours together if you have this flight controller. It's also featured on this flight controller, which you can just about see it there, and that is this black piece of foam. Now, I didn't know I was going to take the bottom off of this, so I thought I'd show you it now. And what this foam is for is covering over the barometer just so that it gives more consistent readings. Now, the barometer is this little chip here. You can see it's got a tiny hole in it. Sometimes they're silver in color, but you can usually tell them because they got a tiny little hole just to let the air in. And when you're putting this together, you want to make sure that the barometer is over the foam. And the foam is a little bit taller than the standoff, so that it just gives a nice squish when it fits together. So yeah, make sure that your foam is in the right place for the barometer before you screw this together. Okay, so here we've got our two flight controllers, and even though there's a bit of a size difference, there's not really a lot of difference between the two other than the processing and that sort of thing. As far as how we're connecting them up, they're actually very similar. This has got a top plate on it which is removable, where you'll actually get to see some of these parts, but you can see where the connections are here. So what I'm going to do is just go over a little bit about the flight controller and some information that you'll probably find useful. Right, so one of the first things that you might see on these flight controllers are these arrows. And what they're basically stating is the forward direction of the flight controller by default. You can actually change the orientation in the model if you wish, but if you set it up with this arrow facing towards the front of the plane, it will all work straight away. We can rotate it if we choose, and there's a command in iNav to actually say that this is the front now. But I don't really want to overcomplicate things too much at this stage, so the first thing that we may need to know about is where we connect our main power. So you'll see here that it says 2S to 6S with a plus and a negative. There are main battery power where it comes in straight from the battery. On this flight controller it's a little bit different. We have our battery positive here and our battery negative here. Obviously that is underneath. You can just see the pads there. And the reason why it's separated out is because we've got this really nice big shunt resistor in here. So that's the battery positive, and the battery negative is here. So even though they're bigger and it's got a bigger shunt resistor, that is the shunt resistor on this one, it's the same thing. I've mentioned the shunt resistor, so I should really explain what it does. What this does is the power will go through from the positive pad on the battery, through the shunt resistor, and then out to the ESC. What this is basically doing is measuring the current that is pulled. So that's all that this is really doing, is measuring the current. I mentioned it briefly, but the other thing that we need to connect is the ESC for our motor, or you can connect multiple motors. So we have two positive pads and two negative pads, and the same is true on this one. We have positive pads for the ESC here, and we have negative pads for the ESC here. You don't necessarily have to connect an ESC to these. These are just positive and negatives, which is getting the full power from the battery. So for example, if you did decide to go for the HD0 digital system, with their freestyle VTX, they supply a battery eliminator circuit, or BEC. You could actually wire that up to the ESC pads. That's our main power sorted. The actual flight controllers themselves have the equipment on there to get it down to the other voltages we need. So there's going to be a voltage for our servos, which our servos plug in here. Also our motors on this flight controller. And our servos plug in here on this flight controller, and also there is two extra servo pins here. For the servo voltage on these, you can see it says VX, and the X is just signifying a power rail. So a power rail is basically, it will take this voltage from your main battery and step it down to another voltage and distribute that voltage around a rail. So our servos, our middle pin here is the power in, and you can see it VX. So with our VX, which is our servo power rail, by default it's running at 5 volts, but if I flip the flight controller over, we should be able to see this pad here. You'll see it says 6 volts. So if we bridge these two pads here, the servo rail will actually become 6 volts. Now, if you're following the kit version where we're selecting any of the servos I've put in the article, they can handle 6 volts absolutely fine. So I'd recommend bridging this. If the servo gets 6 volts, it instantly gains a bit of speed and a bit of torque. So it's well worth doing. If you're using the plug and play, I would recommend leaving it on 5 volts. So don't bridge that at all. With this flight controller, we can actually bridge and raise the VX to 7.2 volts, but most of the 9-gram servos that we get will not handle that voltage. You'll need to get special high volt servos to take that power. So this is where we connect our servos to, the same here. At the back here we have S1, again the voltage at the VX and ground. This is where we would usually connect our motor to. On this one it will be S1. So we've connected our motor completely, we've connected our servos, but what about other things that we need to fly? So first of all, we're using a flight controller, we want navigation, so what we need to do is connect a GPS module. We also need to connect a receiver to get our signal from the radio, and that's where these sections down here come in. So you can see here we've got TX3, RX3, and this one above it we've got TX1, RX1, ground and 5 volt. These are known as UARTs, and that stands for Universal Asynchronous Receiver Transmitter. And basically you can think of it like a USB or a serial port. So we just plug our thing into here and it allows it to talk to the flight controller. There's a couple of differences between this one at the top, which is TX and RX1. So that would be UART1 on the ports page. This one has a 5 volt, so that is getting it from the 5 volt rail. The TX3, RX3, ground and 4V5 is using 4.5 volts when it's connected to USB, but when it's connected to the battery it will be using 5 volts. So these two bottom ones here will actually work when you've got your USB cable connected to. The 5 volt ones won't. So that's why it's a good idea to put the receiver on one of these 4.5 volt ones and the GPS on the other one. It just makes things much easier to set up. Next to it we have an S-bus pad, which is basically going to be the same as RX2, but it has a hardware inverter in between the two. And what that means is it basically swaps the digital signal round. So zeros become ones and ones become zeros. It's just the FreeSky receivers actually have an inverted signal compared to a regular UART. So to actually listen to it, we need to put it through a hardware inverter. So with this flight controller, the UARTs are in a similar place. So we've got TX3, RX3, TX4, RX4, TX6, RX6. We've got 4.5 volt pads here, we've got ground pads here. So we've got a few UARTs here in a similar way to how they're set up here. And for this one, I will be using these two bottom UARTs for the GPS and receiver. So I'll probably put the receiver on UART 6 and I'll put the GPS on UART 2, and then they're both connected to the 4.5 volt rail. So they'll work when we're just plugged in with USB. So we have our receiver and our GPS module, but we need to see where we're going. So we want to connect a camera. Now on the F405, there is a cam pad. There's also this pad here, which is 8 volts. So this is a separate battery eliminator circuit or BEC for the VTX and the camera. So that runs at 8 volts. And then we have a ground. So the camera will plug in here, power for the camera in here, and ground here. So just make sure that your camera can take 8 volts. If not, just steal a 5 volt from somewhere and it will be fine. The video in from the camera will go into this pad, and then the video out to your video transmitter will come out of that pad. And again, we have an 8 volt and ground, which is absolutely fine for most video transmitters. With this one, it's slightly different, and you'll see the same with the 765 series. Is we have C1 and under here is C2, and these are video inputs for 2 cameras, so we can actually switch between cameras if we so wish. Underneath that we have VTX, which is the video out to the video transmitter, and again we have this time 2 9-volt pads rather than the 8 volts, and 2 grounds. And at the top it says VSW, which is actually a switchable power. So you can use that to power off. It's actually running at the same power level as these pads, but you can switch it on and off. So if you're going to do that with anything, it'll be better with the VTX. So then if it's sat on the ground, you can actually switch the VTX off so it doesn't start overheating. But that block here is for our camera, so same as this block here is for our camera. And to be honest, for most of what we're going to do, that's all we really need to worry about. So all these UARTs, we mentioned we have UART 1 here, UART 3 here, UART 2 here, and we can see TX and RX for 5 there, 6 there. They all basically work the same, so you don't have to connect a device to a specific number. The only reason we're connecting, say, a receiver to this one and a GPS to this one is for convenience of having this pad. They all work in the same way. The only exception being if you're using a FreeSky receiver and you need to use an inverted pad, which you need to then use the one with the S-Bus. But that only affects these F4 flight controllers. The F7 and the H7, you don't need to worry about that. So that is a basic overview of the flight controllers. The only other thing that I've not really mentioned is where to plug in the USB. And in this one, it's on the side down here. And on this one, it is going to be, I believe it's this one here. But if you go to the Matex site, their diagrams are excellent. So if you're unsure about anything, the diagrams will help you out. But I think we've spoken about all we really need to with regards to flight controllers at this point. Hopefully you've got a bit of a basic understanding about them now. But what we're going to do is actually now get iNav working on this flight controller. So what we need to do is plug in our USB cable. With the USB, you do need to make sure that it is a data USB connection. So what I'm going to do is just plug this in, and we'll see everything starts lighting up and flashing. So the red light is for power, and the second LED is showing that we have a connection. The other good thing is we've not actually soldered anything yet, and I would encourage you not to solder anything until we go through these first few steps. By plugging it in, we actually know that the flight controller is working, it's not faulty. And we can confirm that in iNav in a sec. We want to make sure that before we do any soldering, this thing is working. If not, we can return it and we have not actually touched it. So there's no question that we've done anything wrong. While we're here, I mentioned it briefly earlier, but there is a thing called DFU, which is basically a mode that allows us to write to the flight controller. You'll see it in iNav in a second. If we can't connect to the flight controller and we have to press a DFU button, it is actually this button on the top here. So you just hold that down when you plug the USB in. So just to demonstrate that, I'll unplug it, hold the button down and plug it back in. So you'll see that this light here is not flashing anymore. We've just got our red power, but we are actually in DFU mode, which means that this can now have firmware written to it. But for the time being, I'm just going to unplug it and get it back working normally. Right, so there we go. We can see our blue lights flashing, and what we're going to do now is jump back into iNav. Right, so you might be able to see that still blinking away behind over my shoulder. And you'll see what has happened in iNav now is we have a different COM port. So for this flight controller, it's COM port 13. Don't worry about these slashes and dots in front of it. They're absolutely fine. All we need to do is make sure that it is the right port for the flight controller. And when you plug it in and it jumps to that number, you're pretty much guaranteed that it's right. But what we can do is try and connect to it. So you can see that's gone straight in. On your flight controller, you may not see any of this. It may just jump to this screen. If it does, don't worry about it. It's absolutely fine. It just means it's running an older version of iNav on the flight controller, or maybe even Betaflight, something like that, so it can't actually get in. So the first thing that we need to do is flash the flight controller with the latest version of iNav. And what flashing means is basically just writing iNav onto the flight controller. So you'll hear this term quite a lot, is this just referred to as flashing. To flash iNav, what we need to do is find out what target our flight controller needs. Now, a target is a specific version of iNav that has been set up for that flight controller. So all the pins on the processor are mapped to all the right places on the actual board itself, and all the components on the board are accounted for. So the first thing that we can check is in this black page, which is the CLI tab. If we just type version and press enter, what we can see up here is our target. So the first bit of text here says iNav, which is our firmware. So if it says iNav, you're good to go. We can carry on and use the next part of the target. If it said Betaflight, we need to find out what target we need to use for iNav. But because this says iNav, we know that the bit after the / is our actual target name. So we can just make a note of that and flash that. If we don't know this, or it's in Betaflight, we can actually try and look it up on the manufacturer's website. So because this is a Matek H743W wing V3, we'll go into the Matek site. But it's well worth checking out the Matek site. They're pretty brilliant. They've got loads of wiring diagrams for everything. But what you'll see up here is they will list the firmware. So for iNav, Matek H743, which we sort of knew. So you can see down here on the Matek site, they've got wiring, iNav mapping, everything. So if you do get a bit stuck about where you can put things, the Matek website is actually pretty brilliant for that sort of thing. But anyway, we know what target we want, so let's flash our flight controller. So what I'm going to do is disconnect, and I'm going to pop into this bottom tab here called firmware flasher. Now what we need to do is find our flight controller, and just to shorten the list, I'm going to type Matek into that box, and now it's easier to find what we're looking for. So Matek H743. Of course, if you've got a different flight controller manufacturer, you can try typing their name in, or if you don't have anything in here, you get the full list of all of them. Next, we need to choose the version of iNav. So because you're a beginner, make sure that this here is turned off and grayed out like it is on here, and we're just going to choose the top version, which is the latest stable release. With these settings, don't worry about no reboot sequence or manual baud rate, but make sure that full chip arrays is on. Even in the future, if you're doing an update to the flight controller, you should use full chip arrays for everything. Next, what we're going to do is click Load Firmware Online, and that will download our specific target to go on the flight controller. And the first thing that we'll see is some more release notes. Now, because we're brand new to this, it's not really that important, but if we're updating, then it's well worth reading the release notes just to see what has changed and if it affects you and what you need to do to update. So it's a very, very useful thing to actually just read through these and see what's up. And once you get to the very bottom of the release notes, you'll see this bar here, which will actually let us know how far we've got with the flash. So what I'm going to do is click Flash Firmware, and you'll see up here it's gone into that DFU mode that I was talking about. If that doesn't happen, disconnect your flight controller, hold the button down and plug it back in, and you should find yourself in DFU mode here, and then you can click the flash button again. If clicking the flash button again doesn't work, close the configurator, reopen it, choose your target, load the firmware and click the flash button again. But that should work absolutely fine. If it doesn't, there is a tool called the Impulse RC Driver Fixer. I'll put a link to that in the video description, and that will sort everything out for you. So that's all you really need to do. The first part of a flash is to erase the memory on the flight controller, And now that it's erased, we're installing our fresh iNav firmware onto that memory. So what I'll do is once this is finished, we'll come back and continue. So we're just going through the last stage where it verifies that everything is correct. It's rebooted the flight controller and programming is successful. So now what we can do is connect to iNav. Now this is the first thing that we need to decide. It's basically the platform that we're planning on using the flight controller in. So we're not using a mini quad, a boat or a rover, but we have got two options for aeroplanes. So we have an aeroplane with a tail and an aeroplane without a tail. So this is quite a simple thing. If it's anything like that, a flying wing, it's an aeroplane without a tail. Our Dolphin is also an aeroplane without a tail. By with a tail, what it means is you have the wing, then you have an extension of the fuselage or booms, and then you have a separate tail at the end. So for example, if we were iNaving this is an aeroplane with a tail. We have our wings, we have a fuselage, and then we have our tail section. So for the Dolphin, we are going to choose aeroplane without a tail. And what that will do is set the basic settings for us. So what has that set up for us? Well, you can see now we have a flying wing on our screen. So because that's there, we know that it's set up a basic mixer for us. And it's also set basic tuning information for the plane. We'll go into that in a little bit more detail later on, but as far as the tuning goes, getting started with iNav, we don't really need to know a lot about it. We can just do an automatic tune, and in most cases that will get you flying pretty nicely. So the first thing that we're going to do to actually set up a flight controller is to calibrate the accelerometer. Now this is on the calibration page, and what you can see here are a few different boxes that are showing the orientation of the flight controller. The thing to take away from this is the order doesn't really matter apart from step one. That needs to be with the accelerometer facing upwards. And notice I'm saying accelerometer here. It's not the flight controller that needs to be facing the correct way, it's the accelerometer. If the accelerometer is on the top of the flight controller, that's absolutely fine. If it's on the bottom, we'll need the flight controller upside down for first measurement. After that, we can go through in any order to get this calibrated. And there's this button up here, which is the calibrate button. The first time we click it, it won't actually calibrate anything. It will just show us a message. But after that, we will actually go through the process. So here's the big question. What's the accelerometer and how do we know which way up it is? So if you've gone for a Maytech flight controller, on their website, they have, as I've mentioned a few times already in this video, they have excellent documentation. So this is the H743 Wing version 3, which I'm using right now on this desk. And if we scroll down, there is a layout tab. And in here, it will actually show you where all the components are. So first thing we need to do is identify which is top of the board, because obviously with this one, we've got this plate on. But we can see these white sockets here, we've got the LEDs here, servos on the left. So we can identify that even though we can't see the top because of this plate, because of where these pins are, where these two sockets are compared to the one on the bottom, we can identify that this is the top, so the top is facing up. So now what we need to do is find out where the accelerometer is. So let's go to the spec and manual. And what we're looking for is IMU, which is the accelerometer gyro chip. So here it says MPU 6000 and ICM 42605. So on this board, there are actually two accelerometers, and they're the model part numbers for it. On the version 3 with this particular board, there isn't an MPU 6000, there is an IMC 42688 along with the IMC 42605. But if we go back to the layout, we can see the MPU 6000, which has been replaced on the version 3, and also the ICM 42605. So these two chips here are the accelerometers, and they're on the bottom of the board. So for the first step on this one, we need the flight controller upside down. Let's check on the F405 WSE just to go over the process again. we've got a photo of the board, but what we really want is just the layout page. And on some of these boards it is simpler because it is just really put in your face. Not this one so much. Again, this is the MPU 6000, which is the accelerometer on that flight controller. Again, you can go to specifications, look up IMU, and you see MPU 6000. So where is it? This is actually on the top. So if you're using the F405 WSE, the first position, you want the flight controller the correct way up. And let's have a look at the 765 while we're here. And again, we're going to go to the specs, and we see we're looking for an ICM 42688 for the accelerometer. If we go to layout, we can see this is the top plate. We've got the arrow, and there's nothing on there at all. And this here is the bottom of the top plate, so you can identify that with the USB connection block. And we can see here ICM 42688, so that is the accelerometer. So again, the F765 WSE will need to be upside down for the first step. F405WTE, which is the replacement for the F405WSE. So we're looking for, again, ICM 42688. This here is the top plate, or the top of the main flight controller, and it's not there. This is the bottom, and they've actually just labeled it IMU, which is a bit easier. So again, F405WTE will need to be upside down for the first step. And this is a brand new flight controller. I don't even think it's out yet, but this is a much better option if you're building something small. We don't need to worry about it with the Dolphin, but for smaller builds, this is probably a much better option than the old F411s. So what do we have on here? We have an ICM 42688 again. So let's go to layout. This is the top, and it's not on there. And this is the bottom, and you can see it's just been labeled IMU, which again is probably an easier way for it to be labeled. So again, with this new flight controller, it would be upside down for the first step of the calibration. So now we know that, let's actually get and calibrate the flight controller. There we go, there's the old F405 WSE. Actually, that is the accelerometer, so it's on the top. We know with this flight controller, it's actually on the underside of this main flight controller plate. So our first step is going to be upside down. So all you need to do for the first step, it doesn't necessarily need to be 100% at the correct angle. The most important thing is that it's still and in the correct general orientation. So I'm just going to put a bit of pressure on it so it doesn't move, and I'm going to click Calibrate Accelerometer. And again, as I said, the first time it just puts a message up on screen. So we'll just click OK, and we'll click Calibrate Accelerometer again so that it can record the first step. This is when we want it to be nice and still. Next, we're going to flip it over, do Calibrate Accelerometer, and we're basically just moving it through all the orientations. And eventually we'll get to the last one. So this one is a little bit more tricky because we have our cable, but I find the easiest way is to get something like this is a charger. So I can just prop it up on the charger, again keep it still and click the button. And there we go, okay. So just a quick thing to mention, when I first went through, you see it detected it was upside down, and it ticked step 2. But Pavel has stated that the correct way to do it is to have the accelerometer the correct way up on the first step. So it doesn't matter if it highlights step 2 or whatever. The accelerometer itself is the right way up. And I have actually done it before with this board where I've had it the correct way up and it sort of fails part way through. So it'll do step 1, but you go on to the other steps and it just stops. If the accelerometer is the correct way up, it just goes through everything. But all we need to do now is save this. So let's click Save and Reboot. and that will save those settings to the flight controller. What we'll do is when it pops back, we'll just verify that this is correct on the setup screen. So the way to do this is on the flight controller you have an arrow, and what I'm going to do is spin it around so that the arrow is pointed away from me. At this point I'm going to click this reset Z-axis button, and all that does is set the back of this on-screen 3D model to you. So all it's done is reset this 3D model. So now if we pull back on the flight controller, we can see the nose is going up. If we lean it over to the side, it leans over to the side. And again, if we push the front down or the back up, it's working perfectly. So while we're on this screen, let's take a look at this information up here. You can see that the pitch and roll is slightly off. Don't worry about it. If it's only a couple of degrees, you don't need to worry about it at all. If you really wanted to get this zeroed properly, we need to do it when it's in the plane. So again, don't worry about it at this point. The other thing to note is this top one here is heading. If we have a GPS hooked up onto this, you may find that the model in the window will just start turning. It could just hover backwards or forwards, or it could just start turning without the flight controller moving. Don't worry about this. If there's a GPS connected and you've not got a proper lock, it doesn't actually know where you are. It doesn't have a heading. In fact, it won't have a proper heading until it's actually moving forwards. So don't worry if the little model in the box starts turning, that's absolutely fine. So our board has been calibrated. So next up, what we'll do is take a look at the mixer. Now you can see by default it's applied a flying wing mixer because we selected aeroplane without a tail, which is absolutely fine, and the settings that we have here are absolutely fine. The main reason I want to show you this is because the important thing is it shows you which pins to connect up the different parts to. So S1 is going to be our motor, S3 is our left elevon, and S4 is our right elevon. So it's worth making note of that before we actually solder anything on. We know which pads we need to use for which functions. So that's another good thing to check this. But also by going through this, back on the setup page, we can actually see that everything is working. The UAV is leveled, we've got runtime calibration, CPU load is fine, everything is safe. Don't worry about compass calibrated. We haven't got a compass connected. It just ticks it anyway. The accelerometer is calibrated. We have valid settings and the hardware is healthy. And if we look up here, we can see blue for our gyro, accelerometer and barometer, which is all the equipment that we have on board. So we know that our flight controller is working fine. And if it starts breaking after this, it's something that we've done. If at this point the model is not working properly, you get some of these aren't working, use the iNav fixed wing group to ask for help. It may be that something's not configured properly, but if we've just done a flash like this, everything should be working. So at this point, we're ready to start thinking about putting this in the plane. So what I'm going to do to finish this video off is just get the plane up here and we'll start having a look at layouts. Okay, so here we have our Dolphin, and let's get the hatches off. And you can see we're basically where we've left it in the last video. Now I know that I want my flight controller to go right here. The reason I want that is because then it will be a nice simple connection for the ESC. I could actually chop these cables down a bit, but also it gets it back out the way. Obviously we need to get the CG right, but the weight of the things in the back are going to get easily compensated for by putting batteries in the front. I'm going to be using probably a 2200 4-cell for this, so I will probably need to have that quite far back anyway. So what I'm going to do is aim to have more weight towards the back than at the front. So what components do we actually need in here? We're going to have our flight controller. Because I want to have a build where it's easy for you guys, the VTX will be in here as well, and the receiver. So the VTX I'll put this side so that we can use this nice little section here. The receiver I'll put on the other side. The GPS, I'm actually going to cut the GPS out of the foam just because I think it will be good to demonstrate how we do that. So if you do want to get a bit adventurous, you can get on with that too. So I will find somewhere to put the GPS, so possibly on a shoulder here. Ideally it wants to be somewhere quite flat so that the GPS antenna points straight up. So maybe even here, just above the motor. The FPV camera, I believe I'm going to put it in this position here. I do like the shape of it with this nose on, but if I put the FPV camera here, I don't need to worry about anything if I take that off and use an action camera. Same as if I put an action camera in there, I can slide the battery back or put another battery in here. There's plenty of options with this plane, which is why I thought it would be a good idea for the beginner series. So the first thing that I'm going to do is actually rip these standoffs out. It would be much better if we had the option. So all 8 of these standoffs are going to come out. These, I don't really see the point of having them anyway because it blocks that screw off, but also I'm not going to be putting anything on there. For a 30 by 30 flight controller stack, that's not a bad idea, but with this particular flight controller and most other wing controllers, that's not going to happen. So knowing approximate positions for where things are going, we can actually confidently start putting together things for the flight controller. So the next thing for consideration is how we're going to connect things to the flight controller. So with this here, this is actually going to be a pretty simple setup. The ESC will solder directly onto there for the main power. We've obviously got our capacitor down here. This white cable here is the signal for the ESC, so that will go onto S1. So I'm going to direct solder that. We also have this blue cable here, which is our ESC telemetry. So I will connect that to, there's an RX8 pad right there. So that will be very useful. So I'm going to direct solder that to the RX8 pad. So that's our ESC completely taken care of. The main battery power, I'm going to loop it around. It doesn't really matter which side, but I think I'm going to loop it to around this area here. That gives me that cutaway if I need to try and tuck it away. Oh, it's just here. So if I do need to tuck it in somewhere, I can tuck it here. But also, I'm going to be making a loom up so that we can run 2 batteries, which I will explain how to do at the time. So I can connect that in here. So we've got a nice short lead here for our power. The video stuff, what I'm going to do is take it from this side, so this block here, but I will take it out around this side and down this side of the fuselage so it's away from the power. And what I'm going to do for the servos, I'm actually going to put pin headers onto S3 and S4 so we can just put the wing in and just plug them in. So for the initial setup, the receiver and VTX will be in this bay, but we'll be moving out onto the wings later on. Also in a later video, I'll be adding smart audio, so that will be connecting to one of these UARTs here. And I'll also add a second camera, just so that there's a few bases covered for if you want to do that kind of thing, but I can do those bits in separate videos after the initial build. So this video has got quite long already, so what we're going to do is leave it there. In the next video, what we'll do is actually start soldering up the iNav components. So it'll be another build type video, and what we'll be doing is soldering on the ESC, our battery lead, the camera, VTX, all that good stuff. We'll be soldering onto the flight controller, and then in the following video we'll start actually configuring it. So by the end of the next video, we will have everything ready to start programming the firmware that we've just flashed. Join me on the next video. I hope you guys found this video useful. If you did, please give it a thumbs up. And don't forget to subscribe and click the bell icon so you'll get alerts to when the next video in the series is out. But also it helps get this video out to more people so they can learn how to do this too. Thank you very much for watching, guys. See you on the next one.